Hi everyone. We'll be starting the session in some time. In the meantime, if you have any queries, anything, please feel free to ask. So basic idea of the whole session is to give you ideas with regards to how to solve methods that will help you to solve faster. The basic idea is that. So we'll discuss that. That's one thing that we'll do in terms of take a few questions and look at ways and means of solving things in a faster way. So we'll take a few questions and take it up. In the meantime, if you have any questions, queries that you want to ask, please feel free to ask. We may have a little shorter session, but we will have a session. So again, the basic, again coming back, it is Quant session, basically focused on mathematics, looking at methods that will help you solve things faster. We will take a few questions, introduce the idea, try to use that idea into a number of questions. What ideas that we are talking about here can be used in multiple questions. It is how you apply those methods that will count. Okay, we will discuss this over a period of time as and when we go forward. So anyone who's writing the aptitude examination, be it CAT, be it IPMAT, be it anything, maybe even any exam which is there which has mathematics in it with aptitude examination, I think that should be fine. Okay. So we will be having the Road to 100 series again. Yeah, we will release one video at a time, and that's what we'll do for the Road to 100 as far as possible. The session is important because in the Quant section, what is important is you need to try to solve things faster. If you're able to solve things fast, you will be able to get more marks, and Quant makes a huge difference in the examination. So if you really want to perform well in the examination and do well, I think it makes sense to focus on doing well with regards to the Quant section. So if you're able to do well in the Quant section, that will help you to score better, faster, higher marks as such. Okay, so let's take a few questions as we said. And try to understand how to go about approaching the same. I'm taking the first question, go to it, try to understand it, and then maybe look at how to go about solving the specific sum. I may have a little shorter session today because I had some dental procedure, but yes, we will have some questions taken up and then try to discuss it. Key is to learn the methods and see how you understand it, and then maybe try and see how to apply to different kind of sums. So there are not too many methods which are there. A few methods. The key is to understand those methods and try to apply it as well as possible. If you get the answer, you can put the answer in the chat box. Any questions, queries that you have, feel free to put in the chat box. This is sum on arithmetic progression, but this is also sum on variables. So if you know how to solve variables, and we will come across with a number of sums like this becomes really easy to solve. If you complicate it, it becomes a little tough, but normally there are very simple methods to solve these sums. And if you're able to understand to solve the simple methods, that will help you really. So if you get the answer, put in a chat box, and then maybe we can discuss the same. So sum on arithmetic progression. Okay, one thing is whenever you have variables in the question, that is the method out here. Whenever you have variables, try to substitute simple values for the variables. Okay, and moment you are able to substitute simple values for a variable, you should be able to get the answer easily. To ensure solving the whole using the variables, convert the variables to numbers. And the moment you're able to convert the variables to numbers, it becomes much easier to solve. We'll take a number of sums. It's also very common in the examination. and it can easily be solved by substituting values. For example, in this case, I'm just giving you a hint. N you can take it as 1. That's the one variable you can take, right? So automatically 2n will become 2 and 3n will become 3. Okay, we can assume n as 1. If you assume n as 1, so automatically you get 2n as 2 and 3n as 3. The moment you substitute that, you should be able to get the answer quickly. Write it out. So let's say n is 1. That means the first term is t. Okay, that means n term is t. That means the first term becomes t. So that is sum of first. Sum of first two terms is 60. So if I say first two terms, sum of first two terms is 60. Okay, which means the second term will become 5t. Because sum of first two terms, because 2n becomes 2. Then sum of first two terms becomes 60. If sum of first two becomes 60, so automatically the second term will become 5t. Now this is an arithmetic progression. Remember, I mentioned very clearly it's an arithmetic progression. So difference between two terms is 4t, which means third term will become plus 4t, which will become 90. Third term will become 90. Difference is 40, 40. So we want the sum of first three terms. The sum of first three terms will be t plus 5t plus 90, which becomes 15t, which means k will become 15. You will get the answer as 15. The theta question, no option. You can use the methods even in a theta question. There is no hard and fast. A lot of people are hesitant to use shortcut methods, saying that in theta question you have to solve the whole sum. No, it's not necessary. All the methods that you use, most of the methods that you use when option based sum can be used in a theta based sum. It's just that you need to know the tricks and techniques to solve. So here, as I said, whenever you have variables, that's a technique. You substitute simple values for a variable. So n equal to 1 when you substitute, that means the first term, sum of first term is t, that means first term is t. Sum of first two terms is 60, that means the second term becomes 5t. And sum of, that means the arithmetic progression, so difference of 4t and 40. So third term becomes 90. So sum of first three terms becomes 15t, which means k, sum of first three terms, k becomes 15. kt will become 15t or k will become 15. That will be the answer. So remember this rule. I'll use this rule again maybe in a few sums that will come later. But yes, it has been used very easy, regularly in the CAT examination, and you can solve this. Okay, we come to the second sum. Ratio is a method which can be used very frequently in a lot of sums. Specifically work, time space distance, and some other sums also. Equations of the sum of them you can use ratio. Ratio is a very effective way of using, but you need to know how to use ratio. We will take a couple of sums how we use ratio in sums of work in two different scenarios so that you understand it and then maybe you can solve it in a better way. Right? So we'll look at how to use ratio in two different scenarios. So try solving this first. When you say efficiency is also work done, just giving a hint, efficiency is also means amount of work done per day per this one by A and B. So when you say A is 25% efficient as B, so if B does 100 work, A does 25 work, or 1:4. Try using this concept. So when you say A is 25% as efficient as B, which means if B does 100 work, A will do 25 work, which means the ratio of the work done is 1:4. The ratio of the work done is 1:4, that means ratio of the days taken will become 4:1, inversely proportional. Work done is 1:4, so days taken is 4:1. Now difference of 4 and 1 is 3. if you look at difference of 4 and 1 is 3, and this 3 dimension stands for 15. Difference dimension is 15, 5 times, which means A takes 20 days, B takes 5 days. A takes 20 days, B takes 5 days. When two people work, one taking 20 days, second taking 5 days, the formula is 2AB upon A plus B, number of days taken. So you can say AB upon 20 into 5, that is AB upon A plus B. 20 into 5 upon 20 plus 5 days. Okay, which is 20 into 5 upon 25. If you solve it, you will get 4 days. That's the answer. A option. We are taking ratios out here to solve the sum. The key is efficiency is equal to work done. The same, both are same. So if A is 25% as efficient as B, that means when B does 100 work, A will do 25 work, or work done is 1:4. Because they are given days, in terms of difference is given in days, 15 days. So you have to convert the work done to days, which means days will be inversely proportional, 4:1. Difference of 4 and 1 is 3. 3 stands for 15 days because difference they said is 15 days. We convert it to days because they are given it in days. 5 times. So 1 will stand for 5 days and 4 will stand for 20 days. So if one person does the work in 20 days, second person does in 5 days, the formula becomes AB upon A plus B. Substitute the formula, you will get the answer as 4 days. That's the answer. Right? And it is sum on work. I mean, as I said, we'll take a couple of sums on work and try to understand. We're basically using ratios. Ratios are the faster way of trying to solve. Only thing you need to be comfortable how to solve. If you're comfortable how to solve, become much better and faster how to solve. So here time taken is given to you. You can convert to work done and then find out the days. If one concept which can be used is ratio, and work sums are quite common in quite a few exams, work, time for distance, etc. It makes sense to learn it as far as possible. If you can learn it, it can help you to be fast. Any new method that you learn initially will be slow, but as and when you start applying it to different sums, different methods, then you tend to become faster. So remember that you tend to be slow initially in any particular method that you use. It's only over a period of time, as and when you start applying on regular basis, then you tend to be faster and tend to be able to solve more. So A you have and B and C together, that's what it is, A and B and C. So A can do work in 3 times the time. So we are given a time. So A takes 3 times the time what B and C together can take. So now time is 3:1. That is time days taken is the same. So work done per day, or what work done per day will be 1:3, reverse. Okay, A does 1 unit of work per day, B and C together does 3 units of work per day. Now they have said A alone can do the work, takes 20 days. So 1 unit of work, 20 days, which means the total work is 20 units. Okay, 1 unit of work by A per day, 20 days, the total work is 20 units. Right, good. Now if all of them work, the total work is 4 units per day. So to complete 20 units, it will take 20 upon 4, which is 5 days. That's the answer. B option. I repeat, the time is given. Time is given as 3:1. So if A takes 3 times as B and C together, right? So B and C takes 1, so A and takes 3 times as B and C. So work done per day is inversely proportional. So A will be 1 and B will be 3. 1 unit, let's say 1 unit per day and 3 units per day. But A alone takes 20 days. So work done will be 1 into 20, 20 units. Total work, that is. Because A takes 20 days to complete the whole work. So total work becomes 20 units. If both of them work, they will take 4 units per day. 1 plus 3, 4 units per day. So to complete 20 work, they will take 20 upon 4, 5 days. B option is the answer. Over a period of time, you should be able to solve this orderly if possible. If you can solve this orderly, that will help you to be really good and fast as far as possible. Tricky some, but try it out. I mean, it's, if you get the approach, it becomes easier. One thing you should know is how to convert percentage to fractions. So 16 2/3 percent is 1/6. 1 is sum of odd factors. 6 would be sum of even factors. Take that hint and try to solve. Assume some values and solve. If you want, you can use the hint from the numbers taken. 1/6, take a hint from the numbers taken. But normally when you assume smaller numbers and try to figure it out. Now, normally people find this particular method very difficult, assumption of numbers. I mean, it is very easy technically, but it is also very difficult to comprehend. It comes with a lot of practice. Okay, let's try to understand this again. When you say 16 2/3%, the first thing that should click in your mind is 1/6. One numerator is sum of odd factors, denominator is sum of even factors. 6, how can you have 6? You can have 6 as 2 and 4 if you look at it. 2 plus 4, 6, 1. And the number which have these factors is 4. If you look at 4 has factors 1, 2 and 4. Okay. I can't take 6 as a number because 6 also has a factors like 2 and 3 and etc. other factors. But if I take a number 4, you will realize that 4 has factors 1, 2 and 4. So automatically 4 satisfies this condition. If 4 satisfies this condition, that means number can be 4. Okay, so when divided by 8, the remainder will be 4. That's the answer. When divided by 4, the remainder is 8. Again, as I said, finding out values, assuming values becomes a little difficult. Here maybe I would have tried 6 number first, but 6 number doesn't give you the answer, because 6, if I take 6 for example, you get factors as 1, 2, 3 and 6. Even factors is 8, odd factors is 4, doesn't give you 1:6. Therefore, you look at something where has more number of odd factors, 1, 6. So if you take a hint from 1 and 6, you will realize factors can be 1, 2 and 4, which is only for 4. From there, once you get a number 4, then when you divide by 8, you will get a remainder 4. That's how you solve this sum. If you're good at assuming, then it becomes easier to solve. This is also one important concept which is there. Something sort of called the multiples. So when you add two numbers, multiples, that's what it's called. So it's an important concept, can be used in quite a few sums related to different aspects. Try solving this. So I'm going to prepare a fruit salad by taking some blueberries, some strawberries, some cherries and some grapes. Used double the number of blueberries as strawberries. So blueberries and strawberries, the ratio is 2:1. And triple the number of grapes as cherries. So 3:1. So double the number of blueberries and strawberries. So this total has to be a multiple of 3. And triple the number of grapes as cherries. This total has to be a multiple of 4. Now when you add two things, if one is a multiple of, let's say, I'm just giving an example. One is a multiple of 5, second is a multiple of 5, the answer will be a multiple of 5. When you add two numbers, if one is a multiple of 5, second is a multiple of 5, answer is a multiple of 5. Here if you look at the answer is 20. 20 is a multiple of 4 if you look at it. Answer is 20, 20 is a multiple of 4, the answer. So which is possible? I know the second number is definitely a multiple of 4. Second case, the total number of fruits of grapes plus cherries is a multiple of 4. So total can be a multiple of 4 only if the first also is a multiple of 4. And for first to be a multiple of 4, multiply this by 4. So you will get 12 fruits. 4 threes are 12 fruits. Multiply this by 4, 12, or multiply this by 4 to make it a multiple of 4. Because of multiple of 3 right now. To make this a multiple of 4, multiply by 4. So 12. 12 plus 8 will give you 20. So then you get all the values. So how many strawberries are there? 4 strawberries, 8 blueberries. Same way here to get 8 you multiply by 2. So how many cherries are there? 2 cherries and 6 grapes. Since you find number of strawberries, the answer will be 4, B option. I repeat, a multiple concept, important concept. So when one number is a multiple of some number, say x, second number is a multiple of x, the answer will also be a multiple of x. In this case, I see that one number is a multiple of 3 because 2 plus 1 is 3. One number is a multiple of 4 because 3 plus 1 4, because total grapes plus cherries has to be multiple of 4. Total blueberries and strawberries has to be multiple of 3. Answer is 20, multiple of 4. Because I see a multiple of 4, I see the answer is multiple of 4. So I know first number should be a multiple of 4. For the first number to be multiple of 4, multiplied by 4, so 3 4s are 12. 12 fruits. So 12 fruits, strawberry also multiplied by 4, 4 strawberries. 8 of the second, you will get the answer. So 4 will be the answer. 4 strawberries, you will get 8 blueberries, and you can find all the values, whichever is required. So that will be the answer. Right? Hope it's clear. So important concept. Multiples is the important concept. Multiples are used in other ways also, but this is one of the ways you can use multiples. Looks difficult, but actually it's not very difficult. It's simple. I mean, for some people you can just make out how many numbers you can get the answer. But yes, it's not a difficult sum. If you can understand the sum, it becomes an easy sum to solve. Yeah, you can use this equation 3, or same concept. You use 3x plus 4y equal to 20 when you use the previous sum. 20 is a multiple of 4, this is a multiple of 4, so this also has to be a multiple of 4. So which means you can take x as 4 and try to solve, you get the answer. This is based on the concept. The concept which is based on is that geometry. If ratio of the length is A is to B, ratio of the area becomes A square is to B square, and the ratio of the volume becomes A cube is to B cube. For any similar figures. for any similar figures, if the ratio of the length is a is to b, area becomes a square is to b square, and volume becomes a cube is to b cube. That's how it is. Now when you say the side of a triangle increase by 20%, so that means suppose this triangle like this, you're just increasing the size by 20%. But the shape is same. That means these two triangles are similar in nature. The two triangles are similar. Okay. Only the lengths have increased by 20%, but the triangles are similar. So product of the circumradius, let the circumradius be C and the in radius be I. So let the circumradius of the first triangle be C, in radius be I. Now circumradius is the length, remember that. The length has increased by 20%. In radius also is the length is increased by 20%. So the corresponding length will also be increased by 20%. So 1.2 C and 1.2 I. It increased by 20%. The corresponding length will also increase by 20%. So old it was C into I. New it is 1.2 C into 1.2 I. It becomes 1.44 CI. Which means increase of 44%. C option. That's the answer. Right? So basically what happens is the property, and it's a very common property used in geometry, where you say if the ratio of the length is a is to b, ratio of the area becomes a square is to b square, and the ratio of volume becomes a cube is to b cube. So that means if I take circumradius is c and in radius is I for the first case, since the triangle is increasing, length is increasing by 20%, similar figures. So C and I are also lengths, they will also increase by 20%. So C will become 1.2 C, I will become 1.2 I. So total C into I for the first triangle, for second triangle becomes 1.2 C into 1.2 I. 1.44 CI, which means it is increase of 44%. So answer will be 44%. My suggestion is follow these sums, even if you don't feel it difficult in the initial period. Try to follow it, try to understand it. Over a period of time, as when we use it frequently, the same methods, you will be able to get it better. The key in any particular methods is try to repeatedly use the method. I'll be using this method in the Road 200 series that we have, which is going on right now. You can check out the Road 200 series which is there. I'll be using it in different cases, but I'm sure you'll be able to, it'll help. I mean, these methods will help you to improve. I'll wind up for today. Okay, so took up a few sums, just glancing to the methods that we use. First we use that variables. Substitute simple values for the variables. Whatever you have variables in the sum, put simple values and you get the answer. Second is we use ratio. Work, time, speed, distance, etc. Ratio is a very common method. The second and third we use ratio, where ratio of the work done is inversely proportional to ratio of the time taken. Same way here, time is given. Ratio of time taken is inversely proportional to ratio of work done. If you can use the ratios effectively over a period of time, you should be able to use it in your mind and solve it mentally. It helps. Okay, next we tend to use substitute numbers. Look at the numbers given to you. Some are odd factors, some are even factors 6 and 1. Look out for numbers that satisfy it. If you can substitute simple values, it becomes easier to solve than maybe trying to solve complicated equations. So 1, 2, 4 is what we use. Then we use multiples. So if one number is multiple of x, second is multiple of x, the sum also is multiple of x. So use that concept. So basically, as someone pointed out, you can also use it as first is a multiple of 3, so 3x. Second is a multiple of 4 for 4y. Total becomes 20. So again 20 is a multiple of 4, 4y is a multiple of 4, so 3x should be a multiple of 4, so x can be 4. Use that to substitute and get the answer. That's second next. And lastly, we use the similarity figures. So using these methods, some of the methods that we discussed, go through it, try to understand it, and that could help. Right. So with this, we wind up today's session. Again, we'll meet again next Wednesday at the same time, 10:15. Good night and see you in the next session.